Okay, so today we're gonna look at mapping out different angles. And so we're gonna look at coterminal, reference, and special angles, and how we put those on a grid. Okay, so coterminal angles are two angles in the standard position that share the same terminal side. So what that means is that with these two arms, I can draw a bunch of different types of angles. So I've got my 30 degrees there, and if I use that same two arms, I've got this 30 here, but if I go around once to there, it's like I'm adding 360 to my original 30. Okay, so I get my 390. So I've come all the way around full circle from my starting point to 360, and then I add on that little piece that's the 30 that's there. It's a different angle. Okay, I've obviously covered a greater arc here than I did up here, but I'm still using the same arms. Okay, if I go in a clockwise direction, okay, or a negative direction. So here we went in a positive direction, came around and added 360. Here, if I go in a clockwise direction, it's like I'm taking my original angle and I'm subtracting that 360. That gives me my minus 330 down there. So that's how you go about finding coterminal angles. So let's try a couple here. There, I got the rules down there for us. Okay. Okay, so let's go ahead and find two coterminal angles to 500. So let's just draw out 500 here. Okay, so this is going to be 360. That's going to take me to another 90 on that is going to give me 450, and 500 is going to be in here someplace. So that's 500. So in a counterclockwise direction, I'm going to go 500 plus 360 gives me an angle of, 500 degrees, 360 degrees, gives me 860 degrees. And if I want another coterminal angle, I'm going to go 500 minus 360. So this is going to find the angle that uses it in a negative direction. And this is going to give me 140. 140 degrees. So there are two coterminal angles for 500. Okay, I'll let you try minus 60 degrees, but let's try one that's at pi over 4. Okay, so pi over 4 we know, and here it's nice to know how much is at each axis. So we know that this is pi over 2 up here, this is pi, this is 3 pi over 2, and this one here is 2 pi. Okay, so pi over 4 is right here. Okay, that's that angle in there. And because it's halfway in between 0 and pi over 2. And now what we want to do is we're going to add 2 pi if we go and find the coterminal arm in the clockwise direction. So pi over 4 plus 2 pi. Now 2 pi can be written the same as 8 pi over 4. Okay, so when I add those up, it looks like 9 pi over 4 would be coterminal. Okay, so that's one of them. It's one angle. Let's do the other. So I'm going to start at pi over 4 again, except this time I'm going to measure back in a clockwise direction. So I'm going to subtract 8 pi over 4. So that's going to give me minus 7 pi over 4. So here we've got three angles using the same arms. Our original pi over 4, our other one that's going in that we started measuring in a positive direction, 9 pi over 4, and then the one that we measured in our negative direction, which is 7 pi over 4. So all three of those angles use the same one. I'll leave that last one, minus 2 pi over 3. Try and find two coterminal angles to that. Okay, so let's move on here to reference angles. So a reference angle is the smallest positive acute angle determined by the x-axis to the terminal side of the angle. Okay, so when I go and draw this angle out, and this is really important stuff because it's going to start to map out the important angles that we're going to use constantly with our trig. Okay, so let's graph out 150. So I know that over here I've got 180. Okay, and here I've got 90. So 150 is between those two. Okay, so this is our original theta, which is equal to 150. Okay, now our reference angle is simply the angle that's between the x-axis and our terminal arm, which is acute. So that's going to be this angle right here. Okay, so if I know that this one is 150 and I've got 180 up to here, then this angle here must be 30 degrees. So theta, or sorry, alpha, our other angle here, our reference angle, must be 30 degrees. Okay. Let's try another one here. Let's try 315. So let's map out 315 here. So I know that 360 is all the way out to here, right? And this one down here is 270. So 315 is going to cut those two in half. Okay, so I come all the way around to 270 and add another 45. And right there is theta, which is equal to 315. Okay, so my reference angle is basically what's between my x-axis and my terminal arm. Okay, so in between there, I know that this whole thing is 360, and 315 is up to here. So my reference angle, this theta, is going to equal 45 degrees. So a couple of things that are really important here to remember is that, first of all, this reference angle is always acute, but more important, or as important as that, is that you're always measuring to the x-axis. Always measure to the x-axis. Okay, let me put an exclamation point there. Ooh, little happy face too. It's tons of fun. Okay, this is an important point. Okay, you never ever measure this angle to the y-axis here. It's going to mess you up. Okay, so let's try a couple in radians. Here, I'll just move this up a little bit. Here, we'll leave my nice little happy face in there though. Okay, and so here, if I've got 4 pi over 3, okay, it's nice to know what's along here. So we know that this is pi over 2, and we know that this is pi, and down here is 3 pi over 2. Okay, and 2 pi. So 0 and 2 pi. Okay, so here we're measuring in pi over 3 parts, right? So it's nice to look at our ends here in terms of pi over 3. So pi is the same as 3 pi over 3. Okay, so I know that I want to go one more pi over 3 from that spot. Okay, so what do you think our reference angle is going to be in here? If this whole thing was 4 pi over 3, what do you think this angle is going to be there? It's going to be simply pi over 3. Okay, I'm going to measure it from the terminal arm back up to the x-axis, and that distance in there, if it takes me 3 pi over 3 to get to here, one more of them is going to get me to 4 pi over 3, so that's my reference angle. Okay, and let's try one more here. These are fun. Okay, if I want to test pi over 6, so I know that right here, this is kind of a goofy one. Okay, that's going to be my pi over 6 right here. And here, the reference angle for pi over 6 is itself. It's pi over 6. Okay, it is both acute and it's being measured from the x-axis. Let's work. That works good. Okay, just a couple of little tips to find these reference angles, because this is going to turn out to be a really important skill. Okay, if you have an angle in here, okay, your reference angle is simply going to be that angle. Reference angle is equal to the original angle. Okay, when I have one in here, okay, in the second quadrant, all right, what I'm going to do is I'm going to count back from pi. Okay, so if this is my angle, okay, my reference angle is going to equal pi minus my original angle. Okay, so for example, if I had an angle of 2 pi over 3, 2 pi over 3, okay, and I wanted to write that what my reference angle is, I know that here I'm going to go that theta is equal to pi. Now pi is the same as 3 pi over 3. 1 pi, right? 3 over 3 is 1. So I'm going to subtract my original angle, 2 pi over 3, and that leaves me with a reference angle of pi over 3. Okay, so that nice, neat little reference angle fits in here, pi over 3. Okay, so when my angle is in the third quadrant, okay, down here, so let's use an example of 5 pi over 4. Okay, same idea. I know that this is pi, okay, except now I'm going to add to try and get that reference angle. So what I want to do is I want to take this whole angle, 5 pi over 4. My reference angle is going to be the whole thing minus pi. So pi is the same as 4 pi over 4. So my reference angle for this right here is going to be pi over 4. Okay, that's the acute angle, right? And in the fourth quadrant, let's pick an angle, let's say 5 pi over 3. Okay, so I know this whole thing is 5 pi over 3, and I know that this on my x-axis here is 2 pi, okay, which is the same as 6 pi over 3. So in order for me to get my reference angle in here, okay, I want to take my 6 pi over 3, so my reference angle is going to equal 6 pi over 3 minus my original angle, 5 pi over 3. So I know my reference angle is equal to pi over 3. Okay. So it looks like in the first quadrant, my reference angle is just my angle. In my second quadrant, my reference angle is pi minus my angle. In the third quadrant, my reference angle is my angle minus pi. And in the fourth quadrant, my reference angle is 2 pi minus my original angle. Okay, and so real quick now, let's go take a look at what this means for us later on. What we're going to try and do is start breaking up these circles. So this circle has 1, 2, 3, 4, 5, 6, 7, 8 parts. So if I take, we know the whole circle is 2 pi. If I take 2 pi and divide it by 8, that means that each section must be pi over 4. Okay, so if this is pi over 4 from here to here, each one of these sections has to be pi over 4. This is 2 pi over 4, which is equal to reduce pi over 2. I just want you to try and go around this circle and find all the different angles in the positive direction. Okay? Okay? So same with this circle down here. Count up all the pieces, figure out what one piece is equal to, and label around the outside in reduced form the angle in radians. That'll set you up for tomorrow.